All right, welcome to Module 7 notes for Intro to Stats at CCD. Module 7, we're going to talk about designing studies. The big thing we're going to focus on in this section is the difference between an observational study and an experiment. So before we get into that, we need to define the two types of variables that we can have with these studies. So you have an explanatory variable, which is an independent variable. So if you think back to your science classes, the explanatory variable is the variable that you have control over. And then the other type of variable we have is the response variable or the dependent variable. So that's the one that you're looking to see how it's affected based on what you do to that explanatory variable. So an observational study is a study where the researcher does not control or manipulate the explanatory variable in any way. So we record the response variable as it occurs. So these are going to be surveys where you go out and you ask people their opinion on something, or you count the number of cars that go through an intersection, or you look at the number of credits that students are taking. It's things that you just observe. You don't control anything of it. You're just looking at how are these things occurring in nature, or how are these things occurring without me having any direct influence on them. An experiment, however, is where the researcher actively controls and manipulates the explanatory variable. And then we look at how changing the explanatory variable may or may not change the responses. Typically, when we do this, we take our sample and we divide it into groups, and each group is given a different treatment. And I have some examples of these coming up. So a case study. Will listening to music improve a student's learning ability? So in this case, our response variable is the student's learning. It's how will they learn the material that they were given with listening to music or not. So if you're doing this as an observational study, all you're going to do is go and ask students, hey, do you listen to music while you study? Do you feel it helps you study to listen or not listen to music? And then you record the responses. So you'd probably have two questions. The first question would be, do you listen to music while you study? Yes or no? Do you feel that listening to music or not listening to music affects how well you learn the material? Yes or no? That's all you're doing. You're not manipulating their responses in any way. You're just looking at what are they telling me. An experiment, however, we're going to split our sample into two groups. One group is going to be given an assignment to learn and take a test on, and they're going to be allowed to listen to music. The second group is going to be given the same material and the same test, but they're going to have to do it all without music. Okay, so then we compare the scores that they received on the same exam, and we look at whether or not the group that was listening to music at the time did better or worse than the group that was not listening to music at the time. And we could even break this up even more. We could split our group into, instead of just two groups, we could split them into 4 groups. And we could have a group that's not listening to music, which is called our control group. We could have one group of people listening to classical music. We could have another group listening to, let's say, jazz music. And then the third group is going to be listening to like top 40 hits, things that you hear on the radio right now. And we could then give them, again, the same materials and the same exam and look at, okay, not only did music help, but did the type of music affect the student's learning ability with this material? So there are a lot of different things you can do with just this one case study for an experiment. The problem with experiments is they are expensive and they are time consuming. Observational studies are much easier, but they don't always give us results that are necessarily as impactful. Right here, association does not imply causation. So for example, with the observational study, okay, I might see a trend that people who say they listen to music helps them study better. I might see that trend in my data, but I cannot say that listening to music causes people to do better on their exams or causes them to learn the material better based on an observational study. However, my experiment where I had a control group, a group of people not listening to music, and then I compared that to the groups listening to the different types of musics, that is the only time where you can say that listening to music caused the students to do better, because I had a control group. So it's very important to know that just because we see an association happening, that doesn't necessarily mean that one thing is causing another. Okay? And that's actually it. This is a very short section. I want to give you another example of how you might think you're seeing a causation appear, but it's not really happening. If you look at the number of break-ins versus the daily temperature. Okay, so we have data of, what was the daily high versus how many break-ins were there. And you look at this and you're starting to see, oh, well, maybe there's an association between the temperature and the number of break-ins. Well, what we can't say is that higher temperatures cause more break-ins. There are other things going on that could possibly affect the outcomes of those. So we just want to be very careful with saying that one thing is causing another. Like I said, the only way that we can say that is if you have a controlled experiment. Not just an experiment, but a controlled experiment. Okay? All right, and now I really am done. Nice short video.